Have you ever just stopped and wondered, what is all this really made of? For centuries, we thought the answer was, stuff, particles, energy, things like that. But what if that's not even the right question? What if reality isn't a thing at all, but a language? Let's get into it.
And that's the classic puzzle, right? Stephen Hawking put it perfectly. We've got these incredible mathematical equations that describe our cosmos with, frankly, terrifying accuracy. But what's the spark? What turns all that abstract math into the chair you're sitting on, the air you're breathing? What gives it life?
Well, this gets to a huge shift in how we're starting to see things. The old way of thinking was that the universe is just made of physical stuff. But the new and kind of radical view is that maybe the universe is encoded by rules, that the information itself, the bit, is actually more fundamental than the particle, the it. So, let's just tackle this head on. Is reality a language? And look, I don't mean that as some kind of cool metaphor. We're asking, what if the universe literally is a mathematical structure? Not just something we can describe with math, but the math itself. This idea has a name. It's the mathematical universe hypothesis, or MUH, from physicist Max Tegmark. And the core idea is wild. It suggests that any mathematical structure that's self-consistent just exists physically. Our universe is just one of these structures, one of maybe an infinite number. So to answer Hawking's question, there's no fire needed, because the equations are the reality.
Okay, so if the universe is a language, it's got to have an alphabet, right? Well, it does. The fundamental constants of nature. These are the recurring characters that pop up in every sentence, every chapter of the cosmic story.
First up, good old pi. Yeah, you remember it from circles in math class, but in physics, pi is the constant of all cycles. It runs the show for waves, for phase, for interference, and here's the really wild part. The only reason you exist as a solid thing in one place instead of being a weird smear across the universe is because of how waves add up and cancel out to create a localized packet. And that whole process, it's dictated by pi. Seriously, no pi, no things.
Next in our alphabet, we've got E, Euler's number. If pi is all about stable cycles, E is all about change. It's the engine of growth and decay. Anytime you have a process where the rate of change depends on how much stuff you already have, think radioactive decay, or even just a cup of coffee cooling down, yep, E is the mathematical character pulling the strings behind the scenes. And then there's phi, the golden ratio. You could call this nature's constant for building things that are meant to last. It shows up everywhere from the spiral of seeds in a sunflower to the atomic structure of weird materials called quasicrystals. Why? Because it's the perfect recipe for packing things efficiently and, this is key, avoiding repeating patterns that could lead to things shaking themselves apart. It's the character for building stable, robust structures. And check this out. This is how these fundamental characters can come together. Euler's identity is like a perfect, short, profound sentence. It connects the constant of growth, E, with the constant of cycles, pi, plus the basics like 1 and 0, and the imaginary number I, all into this one, single, incredibly elegant statement about how reality is put together. It's just beautiful. All right, so if these constants are the alphabet, the main characters, then what's the grammar? Well, that's where the laws of physics come in. They are the rules that tell us how you can combine those letters to create meaningful phenomena. Everything from an apple falling from a tree to a galaxy spinning in space. And maybe the deepest, most beautiful rule in all of this grammar is something called Noether's theorem. The idea is just breathtaking. It basically says that for every symmetry you find in the universe, there's a law of conservation that goes with it. So, because the laws of physics are the same today as they were yesterday, that's a symmetry in time, energy has to be conserved. Because the laws are the same here as they are on the other side of the galaxy, a symmetry in space, momentum is conserved. The grammar isn't just random. It flows directly from the universe's most basic symmetries. But what happens when we're reading this cosmic text and we find a sentence that just doesn't make any sense? What if there are glitches in the code? Well, these cosmic anomalies, that's where physics gets really, really interesting. Because they're a giant flashing sign that our understanding of this universal language is incomplete. And the biggest glitch we're dealing with right now is something called the Hubble Tension. Honestly, it's a full-blown crisis in cosmology. We have two incredibly precise ways of measuring how fast the universe is expanding. And the problem? They give two different answers. It's like reading the same story in two different, perfectly translated languages and getting two completely different endings. And we're not talking about a tiny difference here. When we look at the early universe using the light left over from the Big Bang, we get an expansion rate of about 67. But when we look at the universe nearby, the late universe, using exploding stars, we get a rate of about 73. That gap is way too big to be a simple measurement error. Something is missing from our grammar book. So physicists are proposing a patch for this cosmic bug. One of the leading ideas is called early dark energy. The theory is that for a brief moment in the baby universe, there was a quick burst of some new kind of energy that messed with the expansion rate, and then it just vanished. In our language analogy, it's kind of like finding a silent letter from the universe's ancient past. It's not pronounced anymore, but its effect on how the words and the cosmos are structured is still there. But there's an even deeper, even stranger glitch. It turns out that some questions in physics aren't just hard to answer. They're mathematically impossible to answer. Period. The spectral gap problem is one of these. It's a fundamental question about materials, but it's been proven that you can't create a universal algorithm that can solve it for every single case. And the takeaway from this is just staggering. It means physics itself is not fully computable. Think about that for a second. It means the language of the universe lets you write sentences that are grammatically perfect, they represent totally valid physical questions, but they literally have no answer. There are hard fundamental limits to what we can ever know.
Okay. Wow. So let's take a deep breath and try to pull all of this together. We have an alphabet of constants, a grammar of physical laws, and even some pretty serious glitches in the text. So how do we stitch all that together into one coherent picture of reality?
Well, we can think of reality as being built in layers, like a hierarchy of languages. Right at the bottom, at level 0, you have the raw substrate. Maybe it's just pure information, bits or nodes obeying some incredibly simple rules. Then, out of the collective behavior of all those simple bits, something amazing happens at level 1. Space, time, and causality itself emerge. This provides the stage for level 2, the quantum world, where our alphabet finally comes into play. You have wave functions, with their phases governed by pi, evolving over time according to rules based on E. This gives us all the particles and fields. Then, at level 3, you get the grand cosmic grammar of general relativity, sculpting that space-time into stars, galaxies, and black holes. And finally, at the very top, level 4, you get the most complex patterns of all, life and consciousness, driven by rules of evolution and optimization that make use of constants like phi. You see, each level writes the story for the level above.
And this leads to what might be the most profound thought of all. We aren't just the readers of this cosmic text. We're not standing outside of it looking in. We are written in the text. We're a part of the story, a complex pattern of information that somehow, over billions of years, has learned to read the very syntax that it's made from. Which leaves us with one last, truly mind-bending question to chew on. If this whole universe really is a text, a grand, unfolding story written in the language of mathematics, then what are we? Are we just the universe's way of understanding its own story? Are we the cosmos reading itself into existence?